Right, so we have question number 41 to discuss. As shown in the figure, a horizontal pipe ABC is connected to a water tank with a large cross-sectional area. The internal cross-sectional area of the pipe at B is twice that at C. Initially, a water tap T located at D is closed. Once the tap is opened, now they're operating it, what would be the height of the water level in the vertical tube located at B? Assume that the water flow is steady and streamlined, so we know we are applying Bernoulli's principle, and neglect the viscosity of water. Right. Now let's see. Before that, I just want you all to remind this conclusion that we've gone through in classes. So look at this. If I have water filled to height h, let's consider water coming out with velocity v. I'm going to consider streamline. This is point A, this is point B. So I can apply Bernoulli's principle. I can say pressure at A plus the kinetic energy per unit volume at A. That's going to be 0 because here we're going to consider there's no velocity for the water level dropping. So assume that it's 0, right? There are certain instances where you have to consider the velocity, but here I'm saying it's 0. And so that is 0, then plus the potential energy per unit volume term, that's rho gh. This should be equal to the pressure at B plus 0. 0 is for what? Potential energy per unit volume, that's 0. Plus half rho v squared, kinetic energy per unit volume. Right? So now listen. So I can say the pressure at A is equal to what? Pressure at B. That's equal to what? The atmospheric pressure, because points A and B, they're exposed to the atmosphere. So they have the pressures of the atmosphere. Right? So I can cancel off PA and PB. Then I can say rho GH is equal to half rho V squared. Rho and rho cancels. Then I can say 2GH, the square root of 2GH is equal to what? The velocity at which the water leaves the tube. Right? Okay, that conclusion should be remembered first. So let's remember that. Then the question is easier. It's easier. The velocity v is equal to what? Square root of 2gh. Right. Now we'll be careful. Let's start the diagram first. And now I have this tube like so. Right. So this is the height h. And now we don't know the height it goes to. So let's mark it as h dash. Here the cross-sectional area is equal to 2a. Here the cross-sectional area is equal to a. They mentioned that the cross-sectional area here is twice that of here. Let's see. I can consider a point like this and point like this. Now tell me, if you consider streamline like so, I can consider this point here and this point here. Isn't it like the previous example? If I consider this point here and this point here, isn't it like the previous example? It is. Therefore, I can say the velocity at which it leaves is what? Square root of 2gh, right? It doesn't change. Okay, so it doesn't change. The velocity at which it leaves doesn't change. So v is equal to what? Square root of 2gh. Okay. But now we have to consider the relationship of the velocity here at point A and the velocity of a point like B. Right? Let's consider the velocity at a point like B. Now you know we can apply the equation of continuity. What's that? A1 V1 is equal to what? A2 V2. Because the cross-sectional area is twice here, the velocity should be what? Half. Right? You can understand that because the product of AV should be equal to constant. That's the meaning of what? The equation of continuity. Then if the cross-sectional area is twice, the velocity should be half. So here we have what? V over 2. We can just apply this equation. Here the velocity is V. Right, now I can say something like this. I can say what? Atmospheric pressure here is phi, therefore I can say the pressure at B is equal to what? Phi plus rho g h dash. So Phi plus rho g h dash is the pressure at B. The pressure at B plus what? The kinetic energy per unit volume. What's that? Half rho V over 2 squared. Now that is half rho V over 2 squared, right? But what is half rho V over 2 squared equal to? Now you know velocity is equal to what? Square root of 2gh. V squared is equal to what? 2gh. Then V over 2 squared is equal to what? 2gh over 4, right? Can you see that? Like you can solve this mentally. V is equal to square root of 2gh. V squared is equal to 2gh. Then V over 2 entire thing squared means what? 2gh over 4. Then I can directly write it here. 2gh over 4 because I'm relating the heights here. So rho g h dash plus phi is the pressure at point B, that plus the kinetic energy per unit volume. Because I'm considering this horizontal streamline, right? So here I don't have the potential energy terms. This would be equal to what? The pressure at what? A plus the kinetic energy per unit volume there. The pressure at A is equal to atmospheric pressure phi. That plus what? Half rho V squared. I don't have space here, so half rho V squared. I'll write it here. This should be equal to what? Phi plus half rho V squared. But what is V squared here? 2gh of V squared, so 2gh, that's it, right? Half rho V squared means half rho 2gh. So I get half rho 2gh here. What cancels off? Now phi and phi is cancelling off. Rho terms are there everywhere, rho cancels off. And g terms are there everywhere, g cancels off. And 2 and 2 cancels off. And here 2 and 2 cancels off. So I have what? H is equal to what? H dash plus h over 4. H is equal to h dash plus h over 4. Then h dash is equal to what? H minus h over 4. H minus h over 4 means what? 3 over 4h. That's it. So h dash is equal to what? 3 over 4h. Now I know most of y'all may sometimes be wasting time. So don't waste time. Now I'm teaching this in such a way to make you all understand you can solve these questions faster. This question can be done mentally too, right? So practice doing that mentally. So yeah, so that's done. That's the finalization of the answer, right?